Here's a quick review of some words and phrases which indicate conditional probability. Of course, we have the most obvious, which is given that. If you see given that at the beginning or the end of a probability question, then your sample space is limited to whatever that given statement is referring to. So if it says if at the beginning or the end of the question, for example, if a student is male, what is the probability that the student has long hair? Or what is the probability that a student is male if they have long hair? The if statement indicates the limit to the sample space, which will define the denominator of your probability. And then we also have of, and of would be similar to if. If it said something like, of seniors, what is the probability that the student plans to go to college? Or what percentage of seniors plan to go to college? The of statement tells you the limit to your sample space, and that's your given conditions. And then there's a sneaky one, and the sneaky one is, what is the probability that a something prefers something? So the that a statement is limiting the people that you're looking at. So what is the probability that a senior prefers to eat lunch in the cafeteria? You're only looking at the seniors in that group. You're not looking at the entire population of the sample space. So these put conditions on your probabilities, and they limit your denominator to whatever is included by that phrase. So let's look at an example. Here we have a survey of 239 students, and the respondents indicated which sport they most preferred. And we're going to use the data in the table to answer the probability question. The first one says, if a student is randomly selected, what is the probability that the student prefers golf? So in this one, all of these actually, we're randomly selecting a student. And it says, what is the probability that the student prefers golf? So we're looking at all of the students in the survey, and we're determining the percentage or probability that they prefer golf. So the denominator will be the total of all the students, and the numerator will be the number of students who prefer golf. And then we can always simplify that to a decimal or even a percentage if we want. The next one, what is the probability that a senior prefers football? So this is that sneaky one. What is the probability that a senior prefers football? So we're only looking at the seniors in this problem. And so the total seniors is 59, and that will be our denominator. And then seniors who prefer football. So again, we're only looking in the row of seniors. And seniors who prefer football, this is the overlap of seniors and football, is 30. And then, of course, we could simplify that to a decimal or a percentage if we preferred. Next, we have, if a student is a sophomore, what is the probability that the student prefers cross-country? So the condition here is that if a student is a sophomore, and so we'll only be looking at the total of sophomores for the denominator. Sophomores is 10th grade, so that's right here. And then what is the probability that the student prefers cross-country? So out of the sophomores, the number of students who prefer cross-country is 15. And then the final example here, what is the probability that a student is a freshman given that their preferred activity is basketball? The given condition here is that their preferred activity is basketball. And so our denominator is defined by that given condition, the total number of students who prefer basketball. So we'll be looking at the bottom to determine our total, and that's our denominator. And then we're looking for the probability that the student is a freshman. And so in the basketball column, we're looking at freshman. So these are the types of words and phrases that we're looking for, and the specific wording that indicates conditional probabilities. Good luck with your practice today.